We're going to go over a little practice sheet I made up a long time ago on the production possibilities curve. My intention here, and I don't hold people to this in any way, I certainly couldn't right now, could I? But my intention is that a person would have tried this on paper, perhaps just printed the sheet. That's what I would do if I had a printer handy. And if it were me, I would have tried it on paper blind. Like I wouldn't have looked up the answers. I would have used it as a quiz to see if I was really getting this. And that way, if there were gaps in my understanding, I could identify those, and then I would know where to look to really fill in the gaps. Um, but if you're not in distress, then maybe you didn't do that. Maybe you just looked it up and uh, revisited these things and completed it with resources at hand. What I hope no one is doing is just watching the video for the first time without having tried the sheet, because it will probably seem pretty easy. When a person's doing something in front of you, it tends to seem easy. But then when it comes time to repeat that or to apply that, that's when there tends to be this kind of like, oh. And I've heard that a number of times. Well, it seemed easy, but it's not that easy. So practice is really what it takes, and that's what this is a chance to do. If you haven't done the sheet, stop this thing and do it. Come back. You can do that easily with video. That's a nice thing. But assuming the sheet's done, let's go ahead and run through this thing. First question I came up with was to illustrate the likely trade-offs society faces in the production of automobiles and bread. Tried to get this pretty close to guns and butter, or the homework question from Miller was food and video games. I mean, automobiles and bread. Hopefully that's pretty straightforward at this point. So if we're drawing that trade-off, I would put the A for automobiles on the horizontal axis just because it's lower alphabetically. Bread up here. Recall, we're not saying automobiles cause bread. So if you're looking for how the control variable affects the independent variable, you're on the wrong footing here. It won't play itself out like that in terms of understanding it. No, we're looking at combinations that can be done. Society could devote roughly half the resources to each and produce a combination like this. That would be this many units of bread and this many units of automobiles. Or they could devote more resources to making automobiles and they could produce a combination something like this. That would be making less bread because they took resources away from bread to make automobiles, and more automobiles than this point was, right? It's out here. And they could do combinations like they could do all automobile production and no bread production. That would look like that. That's devoting all of their resources to automobiles. So I'm revisiting that because I want to remind everybody that this line, again, it's not a function like you're used to so much in algebra, where you might be better off to not think of it as a line, is I guess what I'm trying to say. You might be better off to think of this as just the compression of an infinite number of points that to our human eye appears like a line. If I kept iterating and saying that over and over the way I was, this combination, that combination, that combination, eventually I'd have so many dots that they would form a line. That's what we're talking about, is a line of compressed dots, with each dot in that compression representing some combination of the goods that society can make with the resources they have. And I'm just trying to get a nice curved line. Since I drew those dots, of course, I have some kind of humps in it, so I'm trying to get a pretty line for you. Okay, it's getting better. So that's what it would look like. And then the second question I asked is basically, why is it curved? Or is your illustration curved? Well, yes, I drew it curved. So that's not a good answer for why it's curved, because I drew it that way. No, that's not what I mean. Why is their production possibilities curved if we're comparing outputs like automobiles and bread? It's not curved because automobiles are very different from bread. That's not a real good answer. It's not a very good answer. It's not about what the output is. It's about the input that goes into making that output. Okay, so it's curved because it illustrates increasing opportunity costs. As you make more and more automobiles, you give up greater rates of bread. That's what a curve does. If you go out just a little bit on this axis, if you're tracing along this line, you're dropping very fast along this axis. So it's curved because it has increasing opportunity costs, and the reason it has increasing opportunity costs is because of, burn this into your memory, increasing opportunity costs due to the specialized nature of resources. Because some people are, we usually call them mechanics, are very good at making automobiles. So society were making all automobiles, we would have them and all the bakers making automobiles. Are bakers good at making automobiles? Generally, no. Certainly not as good as mechanics. And if all they've done is learn how to bake, they're probably not as good as just a general laborer who knows like the names of tools and stuff like that. So if we're way out here and we say, hey, let's stop making so many automobiles, and we free up some resources, we let loose of some automobiles, the first resources to let go of are the ones that are terrible at it anyway. So you say, bakers, it's been nice knowing you. Go back to baking. And now you've taken something that wasn't very good at making automobiles and freed it up to make bread. Well, they're great at making bread. Hard resources like grain are terrible for making automobiles. Free up that grain, or maybe you could say the land that goes into making grain. Free it up. And of course, what land would you free up first? The land that's best at it, or worse at producing, the worst at producing automobiles. Free up that resource, and boom, you get a big jump in the other thing. So that's why move a little bit here, trace that up, what it corresponds to. Big jump there. Let's think about it in more of a dismal way than making more. Because that's, we're talking, this is the dismal science. Economics is the dismal science. We're talking about increasing opportunity costs. So let's go to the other extreme. Suppose we're way up here. Let's think about what that means, make sure we're clear to everybody. This would mean we would be producing at our production possibilities frontier, so we'd be efficient, but we would be producing a lot of bread and not a lot of automobiles. That's what that point corresponds to. This much for automobiles and this much for bread. Let's say you want to get some more bread. Well, you already have so much of the resources of this economy producing bread and not much producing automobiles. What's left to produce more bread? Now you have to take mechanics. You have to take petroleum products, things that go into automobiles really well, and put them to use to get more bread. And they are not very good at it. So you can only get a little bit more bread, but they were the things that were really good at producing automobiles. So whoosh, you drop a lot of automobiles. As you move toward an axis, your opportunity costs, that is how much you're giving up of the other thing, are increasing. Increasing opportunity costs, and it's because of those resources that we described, specialized nature of resources. So that's a lot of review on that. Hopefully you feel super comfortable about that so far. Now let's really see if we're getting it and describe some events. First event that we have should be pretty familiar. I think it was really close to a homework question. On your model, illustrate the likely effect of an influx of ordinary laborers. Our homework question just said immigration that could do either one. That's what I mean by ordinary laborers. Just people who can work a 9-to-5 job, do what they're told to do. They're not particularly trained in automobile or bread production. Well, they could go to work producing either automobiles or bread. Now, some people, when I see these in person and I'm walking around a room watching people, going like this, looking at this sheet and all that stuff like I do in person, some people make this mistake. It's not a bad thing. It's not exactly correct. Some people draw this like this. They have a belly out here in the middle. And the reason is because they're ordinary laborers, so they could be put to use for both things. But since they're not specialized, they think, by the way, this is a mistake, okay? Don't take a snapshot of this, take it out of context. I did not say this is the correct answer. I'm saying it's not exactly the correct answer and explaining why. People think, well, they're not specialized, so it wouldn't raise this. Untrue. It would raise this. What I'm saying the correct answer looks like is this. Let me just redo it all together. this thing would expand both ways along the axes too. For my second question, what do I call it? Number 3 is how I asked you to label that. The reason it goes out of both axes, let me focus on this one because I have some experience with this. Okay, here, this society is not producing any bread, totally producing automobiles with all the resources they have. They get more resources, these ordinary laborers. And I'm saying they can still produce more automobiles even if they don't produce bread. And here's why. I've changed my own oil many times. I like to change my own oil because I like to have, in spite of what we've talked about somewhat with specialization, I like to have a range of skills. I feel like if I pay somebody else to change my oil for me, I'm losing twice. I'm spending money and I'm getting dumber because I'm not taking the experience to remember how to do it myself. So I like to do things like that. In spite of everything we've said about the gains from specialization. So when you change your oil, it goes like this. You climb under your car. You put your car up on ramps. You do it yourself, like in the driveway, like I do. You drive your car up on these things. They're called ramps. They elevate the front of the vehicle. And you get on what's called a creeper. That's a flat board with wheels. You lay on your back, okay? And you try to put everything you're going to need down there under the bumper within arm's reach. You almost always forget something, though, or something doesn't work according to plan. So what happens is you get down under the car, okay? You have an oil pan there. That's the thing to catch the oil. Maybe that's not the best term because oil pan is the thing up on the motor, but it's a pan to catch the oil, something. You slide that underneath the oil plug, and you take a ratchet and a socket. I think they're all metric now. Everything I have has been metric. I think mine's like a 12 millimeter socket on the truck. Put that on. You loosen the oil plug and watch out because you want to have your engine pretty warm to do this. So you have hot motor oil coming your way. And then it starts to run all over that ratchet and down your arm, and sometimes it burns and all that. And theoretically and ideally and hopefully you get all that oil to fall in that pan that you laid down there. Okay. And while that's draining, then you take that oil plug and you're very carefully, the plug there, you very carefully set that down. Don't get any dirt on it. Make sure you don't lose the little O-ring that's on there if there's one on there. And then you loosen the oil filter. And that's usually someplace really hard to get to, and you got to wrap your arm around it, something like this. And you got to lay right under it while you do it. It's I don't know, it's a cruel game they play at the car manufacturers. And you loosen that thing, and the oil starts dripping from that, usually almost always right down your arm, and very often in the general direction of your face, and it's hot motor oil. So pleasant that is. But anyway, if you have some experience, you can dodge it. It's not that bad. Sometimes that thing gets stuck, okay? Or sometimes when you go to get that plug, you got the wrong socket. As I said, I think 12 millimeter springs to mind, but maybe I'm wrong, okay? So what happens is you get under the car, and you're on this board, laying there, you're crawling down like this, and you're doing this, and then you realize something's not right, or you can't get that filter off, it's not right. So then you cuss at it for a while, and that doesn't actually fix it. Everything's still the same as whatever the problem is. And then you climb back out from under the car, and you go to your toolbox, and you get what you hope is the correct socket, or you get, if you didn't remember it, you get your oil filter wrench. There's a wrench for that. It's like a strappy thing. Or if you have to, you get a big screwdriver to jam it through. That's a commitment, though, to untwist your oil filter. And then you get that tool, and you go back under, and a certain percentage of the time, it still doesn't work, and you cuss at it some more, and then you climb back out from under the car, and you go over and you do it again and again and again until you get everything you need, and you get it done. You get the filter off. You put a new one on, by the way, and then you put the plug back in. You go up top. You put in the correct amount of oil according to the owner's manual. Make sure you put the cap back on, run it for a minute, make sure nothing's leaking. Boom, you're done. That's how you change your oil. I bet you didn't know you were going to get that in your econ class, did you? That's $30 just saved for you. You're welcome. But that's me having some skill at doing it. I know how to do it. That's just me doing it by myself. And I'm pretending to be an auto mechanic because I can at least do that auto mechanic task, okay? What if I had somebody there helping me? This ordinary laborer. Now, instead of just cussing at it when I have the wrong tool or when I need an additional tool, and then climbing out from underneath, see how I lose that time? If I have somebody there to help me, I can say, hand me, I had the wrong socket, hand me a 13 millimeter. Let me try a 13 millimeter. Boom. Time saved. I can crank out more output per hour with the aid of the ordinary worker. So even if we didn't produce any bread, the auto mechanic kinds of people could produce more automobiles with the aid of the additional resource of the automobile, the ordinary worker. That would also be true for the bakers up here making all the bread with the help of the ordinary workers. That's why it goes out on all the way around, not just bellies out toward the middle. Okay, so that's a long explanation for that, isn't it? But you learn how to change oil. On your model, illustrate the likely effect of a massive swarm of locusts. I believe it was in the fall, the continent of Africa was having a problem with a massive swarm of locusts, as a matter of fact. Label your new line number 4. Okay, well, if we're talking about a trade-off between automobiles and bread, this is a pretty short-term analysis, okay? We're not thinking about, like, the population starving because locusts ate so much of the food or something like that. That would just cut down on both. That's too long-term, just a short-term kind of thing. In the short term, do locusts affect the production of automobiles? Not really. For those who maybe are a little lost here, locusts are insects, and they eat most anything green, including grain, which is used for bread. Okay, but they don't eat automobiles. They don't eat automobile workers, and it would have to be quite the swarm of locusts to jam up assembly line equipment. It ain't going to happen. But they'll eat the heck out of grain, and they'll hurt bread production. So this massive swarm of locusts effect is a pivoter here for us. This wouldn't change. This would fall in. So number 4 should look something like this. I'll make it dotted, so it's because I used the same color as my original one. Number 4 should look something like that. It should pivot in on the bread side, but not on the automobile side. Number 5, on your model, illustrate the likely effect of a strike in the steel industry. Label your new line number 5. Okay, well, automobiles and steel versus bread and steel. Automobiles frames are made of steel. I think there are a couple models out there that they have made car frames out of aluminum, but they're pretty few and far apart, the models that they're doing that with. Generally, automobile frames are steel. Engines are made of steel. Pretty major input to the production of automobiles. So if something is stopping that supply chain, that's going to be bad for the automobile production. Now, grains are planted and harvested with tractors and combines, which are made of steel, just like they're machines very similar to cars in a lot of ways in their mechanics. There's a lot of stainless steel used in mass production of foods, but those are durable goods. Those things are going to be around for a fairly long time. They're not a raw material like they are for automobiles. So in any kind of short-term analysis, we're looking at the same thing as we had here, but just switched, where bread production wouldn't really be affected. We'd just keep that the same, but automobile production, with this disruption in the supply chain for a major input, is going to start to look like this. It would pivot in. So that's what number 5 on the sheets should look like. And now number 6, I'm particularly proud of. I came up with this on my own. Create a new model. Think of 2 goods that might not exhibit increasing opportunity costs. And I'm just left the framework there, meaning draw it. What would it look like if there aren't increasing opportunity costs? I like this because if you really get something, you can counter against it. You can argue against it. That's what this question is about. Tell me something for which this isn't true, now that this is feeling comfortable. If we don't have increasing opportunity costs, that means our trade-off in the production of the goods is at some constant rate. So it doesn't have to be a 45-degree angle. It could be like 3 to 1 or something. You're talking about a good here, something, I'm not going to tell you what just yet, a good here, for which there's some constant rate of trade-off. Why would that be? The resources that go into it are interchangeable. So what's an example like that? What would something, this is number 7, why might there be some curvature and trade-offs, some trade-offs more than the others? I guess I kind of just said that. That's because of the specialized nature of the resources. Some resources can go into either good at a constant rate of trade. And that's the cause of the increasing opportunity cost. But what kind of goods might these be? Example that comes to my mind are leather jackets and leather gloves. So I could say jackets, well, actually I should say gloves down here and jackets up here. I'll put an L in front of them, LJ and LG for leather jackets and leather gloves. And that's because who makes leather jackets? Tailors, I think you'd say. Who makes leather gloves? The same people. What kind of other raw materials go into those? The same threads, the same insulation, the same everything. Can you make one pair of leather gloves for every jacket that you make? No, because a jacket requires more square inches of leather. So you might be able to make, I don't know, 5 pairs of leather gloves for each jacket. So that would mean you could use all the resources you have and make a lot of pairs of leather gloves, or you could use all the resources you have and make a few jackets, or you could have some combinations in between. But because the inputs are the same, the opportunity costs are constant. And it's not because the things are similar. You might be looking at these going, well, they're similar. I get them both at Wilson's. It's not that. It's because the inputs that make the things are similar. And yes, the outcomes happen to be similar, but that isn't the cause of the linear trade-off that you face in this, that the outputs are similar. That's not the cause. It's the inputs that matter, the specialized nature of resources. So hopefully you got that. We're going to have a discussion board. If you know what? I might just have might just ask you to go ahead and just give me your example of something like this on the discussion board. That way we can check, make sure you're getting this stuff. I hope that was a little fun.